guys, I'm Boon. Before going for the experiment, I will introduce my group members now. With Amos, the vegan, Dinesh, and also Chen Wei. They are going to present their topic in this video. Please feel free and enjoy it. For now, our topic for the experiment is the making of hot ice. Why we choose this experiment is because it is related with the chapter 5, the carboxylic acid chapter that we learned before. And why our experiment is related to this chapter 5 carboxylic acid is because the reagent that we use in this experiment is the vinegar, which is the acid is to be used in this experiment. For the introduction, the experiment is about how we're going to make the hot ice. By the material, which is the organic compounds. The organic compounds is the chemical compounds that contains the carbon and hydrogen in it. So we are going to use the reagent such as the vinegar, the acid, the baking soda, can also naming with the chemical naming the sodium bicarbonate. Okay, the combination of these two reagents will produce a product which is the sodium acetate. The solution of this sodium acetate need to be undergo the boiling, cooling and evaporation process in order to get the solid form or crystal form of the sodium acetate so that we can use it to make the hot ice. Other than that, we can also use it and put it in the bags so that we can make it become a reusable hand warmer. For the objective for this experiment, actually we learn this so that we can make the reusable hand warmer by this basic kitchen supply, which is the common material that we can find in the daily life.
So hi everyone, my name is Dinesh Rat. So today I'll be presenting about the apparatus and materials needed to prepare hot ice. So firstly, we need baking soda. Secondly, vinegar, followed by basin, pot and spoon. So these are the materials and apparatus that you need to prepare hot ice.
So today I'm going to demonstrate on how to make the sodium acetate or hot ice. So let's start with the video. So for the first step, we're going to pour this vinegar inside this pot. So we're going to pour like 1 1/4 of vinegar inside this pot. And then we're going to add baking soda. Three tablespoons should be enough. So when you add baking soda inside the vinegar, right, can see here like they fizzing. So you're going to stir it. After, make sure that there's no like a chunk of baking soda. Make sure that it's dissolved completely and the liquid is clear. After that, you're going to turn off the stove. So we're going to boil this mixture until 90% of the liquid is gone. So after 90% of the liquid is gone, we're going to turn off the heat immediately. So now we're going to pour this liquid inside a jar. Okay, we're going to put all the liquid inside the jar. Then we're going to close it. We're going to close it and then place it inside the ice bath until it's reached the room temperature. So now we already take this thing out from the ice bath, and now we're going to pour it and to see whether it's worked or not. So after you pour the sodium acetate in this small cup, so this is the result.
So hi guys, today I'll be talking about the result. So in this experiment, there will be two reactions occurring, which is the double displacement reaction and also the double decomposition reaction. So firstly is the double displacement reaction. So in double displacement reaction only involve vinegar and sodium bicarbonate, which is the baking soda. So once baking soda reacts with vinegar, it forms sodium acetate and carbonic acid. So that's for double decomposition reaction. So the next reaction, which is the double decomposition reaction, it only involves carbonic acid. So why is it carbonic acid? Carbonic acid is an unstable acid. So when it undergoes double decomposition reaction, it will be decomposed into water and carbon dioxide. So that is why the final result will be sodium acetate, carbon dioxide, and water. Instead of carbonic acid, it will form carbon dioxide and water. And also in this experiment, we found out that the solidification process occurs in a very short period of time. So as you can see, when we pour the hot ice, it forms sculpture in a very less period of time. So it shows that solidification process occurs very quickly. So nextly will be the crystallization process. So when we cool down the solution of sodium acetate below its melting point, it turns from liquid to it will turn into liquid from liquid to crystals. So as you can see, when we this is the freezed sodium acetate. So when we scrub the surface of the freezed sodium acetate, we can obtain crystals. So it shows that crystallization process occurs in sodium acetate. So crystallization process is an exothermic process which releases heat to the surrounding. So that is why one of the purpose of sodium acetate is to prepare heating pads. So since it releases heat to the surroundings, right, when it turns from liquid to crystals, so that is why it is used as heating pads in industries. So that is all from me. Thank you very much.
Hi everyone, my name is Amos Alexvira and I'm going to talk about the discussion for this experiment. So in this experiment, we used sodium acetate as a hand warmer. This is because of the exothermic reaction that occurs, meaning that when the exothermic reaction occurs, it releases energy in form of heat when it is triggered. So what is exothermic reaction? Exothermic reaction is a chemical reaction that releases energy in the form of heat, and this will cause the temperature of its surrounding to increases. So next is how to use the hand warmer or to activate the hand warmer. So in order to use the hand warmer or to activate, you just need to pour the sodium acetate into a resealable bag and add a crystal into it. So by adding a crystal into it, the hand warmer is automatically activated. So what if you want to reuse the hand warmer? So if you want to reuse the hand warmer, you just need to put the hand warmer back into a boiling water. So this will cause the sodium acetate to re-liquefy, and you just need to let it to cool down in order to reuse it again. So do you know what makes the sodium acetate so special in this experiment? The interesting thing about sodium acetate in this experiment is about its freezing point. So for the sodium acetate, the freezing point of the crystal is really high, over about 130 degree Fahrenheit. When you heat your sodium acetate solution, you took it above its freezing point, and when you separate out the crystal and cool it down, you took the solution below its freezing point, but you did it in such a way that the sodium acetate was unable to form crystal or to freeze. So when you drop the crystal into the solution, that allows the liquid to crystallize faster. So from this experiment, the sodium acetate that we produce is completely safe and it is non-toxic. So the sodium acetate we produce in this experiment can stay warmer for 2.5 hours, and when it cools down, you can reuse it again by boiling it again. So that's all from me. Thank you.
Hi everyone, my name is Davigan and I'll proceed with the conclusion of this experiment. So based on the experiment that we conducted earlier, we can actually learn how to make sodium acetate, which is the hot ice, by just using basic kitchen materials. For example, the materials that we used in this experiment is just vinegar, baking soda and also water, where we can actually find these materials easily in the kitchen. And then besides that, this experiment also relatively simple and also inexpensive to be carried out by anyone. From this experiment, we can observe the reactions that happens between baking soda and also the vinegar when they are added together, and this reaction actually produce three products, which are the water, salt, which is the sodium acetate, and also carbon dioxide gas. The carbon dioxide gas is released, and this gas can be identified when the bubbles form in the solution. Besides that, sodium ion and also acetate ion are also produced in this solution. Later, these two ions are combined and form sodium acetate, which is the hot ice. And then we can actually use this hot ice as eating pads or also as a hand warmer. Through this experiment, we can actually improve our creativity, as we are just using simple basic materials to produce something useful, which is the hot ice, by the implementation of chemistry knowledge in the experiment. Next is the reference. So for reference, we actually use Wikipedia to learn on how to make sodium acetate. Besides that, we also use YouTube to watch some videos on how to make simple hot ice by using basic materials. So that's all. Thank you.